level for today's lab. They were probably thought that will give you guys data. So anyways, I'm just going to explain you, and you can have your data sheet ready as I explain, so you can kind of fill your data sheet. Okay. Oh yes, of course. You didn't do it. You have to know what's going to be in that lab, right? Otherwise, if I tell something here now, you will probably not understand. So if you have done that, I clearly mentioned that in your week 2 folder, right? Did you guys not upload the dry lab? Like, it's not dry lab, actually, it's a wet lab, but, we put it for the online only, okay? And then we're going to provide you the data. So if you have not done, I think that after the class, you should write it and know exactly. Otherwise, it will be difficult that when I explain, you don't understand. How many of you did the notebook relap? Well, it's a pretty simple that, you just write like, let me just put it here in the whiteboard. So what goes in here is usually title, right? So your experimental title. So today's experiment is chemicals in everyday life. What are they and how do we know them, right? So you just have a quick experiment 7, title is already in the book. So you write the title in your notebook. First 2 pages, as I mentioned, leave it for table of content, right? So table of content is a kind of like this. In the first 2 pages, you can kind of list your table, like make a table there and, sorry. You guys already write in the General Chemistry 1 also, right? So here you have a title of like, the experiment number. One, right? As you go next week, you can start filling it. Title of experiment, right? And then here date. And then here like pages. You want to make the notebook nice so that you know that where it is experiment in the pages, like as you start the progressing your week. So if you're doing experiment 1 in your table of content, this is the very first page of your notebook. Okay, you write the experiment like probably if you write 7, you write 7 here, right? Experiment, just not write number here, just say number here. I just say experiment number instead of 7 anything, just write number, right? All right, so if you want to go from the book, then you just write experiment number 7, right? And then title here. So just type chemical in everyday life, right? So you just kind of fill in within this table. Don't go here. It is not letting me do that, I think. So let me just like this. It's kind of a little bit difficult here. So just fill in this table the name, okay, title of the experiment, then which date, like today's date, right? You did in the today's date, this one. So just fill in here like today's date, 02/01/2021, right? And which pages? I think you start for the experiment, first experiment that you start of the semester. Yeah, that's fine. But some of you who didn't do it, I'm just explaining it. So just write like a 1 page to like how many pages it takes, up to page 1 to 3 or 4 or 2, right? So how many pages it takes from page this to this. Great. So this is for today's experiment. And another page you go, you write the title, right? Chemicals in everyday life, and then date, right? And then objectives. This is for your first page. As you go another experiment, you fill in another experiment here, right? Maybe next week, like experiment, like the 20 or something like that, right? I don't know which one is that. So go ahead, put there. Like as you progress, you kind of start filling your, the table of content also, and make sure that you have a page number for your, the notebook, right? So in like if you do chemical in life one, page number one, just page number one, how many pages take by this chemical equation? So just 2, 3, go paging like in your notebook, and then write like title on the very top of the first page, and then next you're going to write date, or you can write date at the left right corner here also, and then you can write objective, right? Then you can write the chemicals and equipments used for that experiment. List that, right? Sorry. And then you're going to write the procedure, like MSTS is another important thing, MSTS of chemicals. If you're using chemicals, suppose like if you do this experiment today, like experiment 1, then you will be using sulfuric acid, right? You're using bleaching and stuff. So those chemicals, you need to mention that health hazard, right? MSTS is a material safety data, right? Sometimes we just call this STS also, right? M is a material, S is a safety, D is a data, and S is a material safety data sheet, right? And kind of fill in a sheet or material safety data. So those things, that, as I mentioned in last class, it has a huge information, but yeah, pre-lab use your journals, okay? Journal is like, the where you write one by one, like these things, title, date, objectives, and chemicals. You have to write in your notebook, okay? You have a notebook like this. I just want to show you some of this sample from another lab also. So this is your table of content. Did you see it? So first page. And second page, you can leave it open. And then from the other page, you can number here and then title like this. See here, the objective, the experiment title and date, right? And you see the objective, and then, this one is organic chemistry, so they require also background. But you don't need to write background for your general chemistry. So what you do is you kind of list the chemicals here, and then also list your safety data, right? So you see here the safety data they provided, like the hazard like this. So you kind of provide like this, okay? And then you start writing the procedure, like see here, procedure is stepwise, I'll just put here. So that kind of stuff. And right up to the procedure, what you're going to do for that experiment. Before you come to the lab, you have to know, okay? And once you're done, then scan it, only procedure, okay? Up to the procedure. So what is goes in your pre-lab notebook, that's pre-lab. Pre-lab means before the lab, right? And you have to do that before the lab. Before the lab is scheduled of every week, okay? Next week lab, you have to look at that. What is that lab? Yeah, pre-lab questions are one, pre-lab quizzes are one, right? Pre-lab notebook is other thing. So everything is kind of like a different here. Those are all before the lab. So this week, what you have to do here is like, I just want to show in Blackboard because I don't want to make you guys confused from the beginning. Let me show you what you have to do again. Just give me a few minutes. I'm going to upload other file here. Okay. Just a few minutes, please. Yes, sometimes the login program. Some way it didn't let me log in 2 times. All right, so I'll probably at the end I'll show you in the semi screen. Yeah, there is a Dropbox for pre-lab, right? So you have to upload your up to the this like up to the procedure here. One more thing missing here. Procedure and stepwise. I also put that in like a week activities. So you guys read that week activities. When you open the week folder, you see the week activities, week objectives there, right? So make sure that you read that activities so that you will know that what you have to do, right? So the stepwise process, like step by step. Oh, the another Dropbox will be available soon. Okay. So I always post the after lab Dropbox after lab. Okay. So the Dropbox available there is for your pre-lab scan from the notebook. And then there is a pre-lab quiz there, right? So you have to finish that quiz before pre-lab, right? And also you have
I'm sorry, can you hear me?
write in your notebook and scan and upload there. So 2 things you have to do for this lab. One is pre-lab quiz. That's already there, I think. It's already available. Did you not see it?
Yes, it's
Let me know if you
Can you
don't
hear me?
see it. I think I posted that last Friday. And you got to look every week your folder before lab and then also after lab. So before lab assignment, I put before lab, and after lab assignment, I put another, the after lab assignment like a Dropbox. I will open the after the lab. Okay. So I haven't opened another Dropbox in the week 2 folder. So after this class, the maybe up to Friday next week, because your lab is not due until the next week. So this time, so I will open that soon. I can hear. Can you speak it?
Hello, can you
Go
hear
ahead
me?
and speak.
Hello? Can you hear me?
I don't hear you. You want to? Oh no, I don't hear though. Something. Okay, let me just. Can you speak now?
Hello?
Yes. Go ahead.
Okay, it's because I was wondering, I was very confused because there's only one Dropbox available, but I'm not sure if it's for the notebook or for the pre-lab.
Didn't this notebook Dropbox say notebook scan here? Something like that? It has label there, right? Notebook scan.
Yeah, so that's just for the notebook, then where do we turn in our pre-lab?
The pre-lab is like, there is a quiz. Pre-lab for the quiz.
Okay, so we don't have to do the actual pre-lab, we just do the quiz?
Yeah, sometimes we have a direct pre-lab from your lab manual upload there. At that time, I will open the Dropbox, but this time, those, the pre-lab quiz are your pre-lab, okay?
Okay, so
Questions.
that was my question, because
Okay,
I was very
so that
confused
makes
what we had
sense.
to turn
You
in.
guys finish that quiz?
Yes.
Yeah, the questions, like a pre-lab questions, are same like a pre-lab quiz questions. So sometimes we type and put it like a pre-lab quiz. Sometimes we just ask you to, complete your pre-lab and upload in a Dropbox. If you don't see the Dropbox for the pre-lab questions, then
So
you will see the quiz there.
if I turned in the wrong thing in the Dropbox, will it let me turn in something else, or what do I have to do for that?
Did you turn in something wrong?
Yeah, I turned in the pre-lab because I was under the assumption that we had.
Oh, okay. There might be more another chance there. Like, I always put 2 chance or 3 chance. I'm not sure that how many chance I put in there. So, you may be able to again, download there, and I will look at the second one that you downloaded. Okay.
Okay, and if it doesn't let me, is it okay if I can just email it to you?
No, don't email me because I can't keep track because I have almost like 150 students. I get crazy if I get the things in the, and then I don't know which section it is. Okay. So what I want to do is, if you have that problem, let me know. I will open the more time for the Dropbox. Okay.
Okay, thank
So
you.
you can submit another time. So that things what you submitted, it will stay there, but I will not check. But you can again submit it another time. So I will increase the submission time. Okay. How many of you did that wrong things? All right. So all right. Try yourself. I think I always put a 2 to 3 submission time, but I'm quite not sure. I don't remember right now how many submission time I put for your Dropbox, like for the notebook. Fine. If you turn in pre-lab and notebook in the same one, I will just take the one. That's fine also. That's no problem. But if you just turn in like a pre-lab questions instead of pre-lab notebook, you'll have to submit notebook scan to me again. Okay. So yeah, in case if it doesn't allow you to upload again, let me know. I will increase the submission time so that you can submit again. Make sense? Is that good? All right. So all of you make sure that any lab, like except like a problem set, you don't have to write the pre-lab and stuff. But other than that, all the experiment that we have, make sure that you have up to section 1, 2, 3, 4, right? 5, 6. This up to section 6, you have to complete in your notebook. And then, as I just mentioned, that page it, right? And then have that scan, and the upload in Dropbox label with like a pre-lab notebook scan. Like sometimes I'll just pre-lab notebook scan for week 3, or sometimes I just keep the experiment title pre-lab of notebook scan experiment this. So you just find that before the lab and upload it. And then there is always either quiz or another Dropbox for your pre-lab questions. Okay. If we don't see the another Dropbox for pre-lab questions, you just look at that quiz and then just complete the quiz. If you see Dropbox for pre-lab question, maybe that week you won't have your quiz. You just upload your pre-lab questions. So every week we will have either pre-lab question Dropbox or quiz there for the test. Okay. So you can find one of those. And sometimes in a quiz, we might have some question, upload your, pre-lab questions. Some of the question will have answer there. So make sure that you read the question properly in pre-lab questions. If there is one question asks you upload your pre-lab questions, then you upload in that one. Okay. So that's how it works. And then also for the post-lab questions and the laboratory report sheet, we also have another Dropbox that usually I post not to make you guys confused. I just post that after the lab. Okay. I'll open another Dropbox after the lab, and where you're going to scan your report sheet, right? So you have this kind of report sheet for today, right? So you complete it, write it, and you have a post-lab questions also here, right? Sometimes it depends on like professor to professor. Sometimes they have the post-lab questions plus report sheet also mixed up there. Like one of the question will ask you upload your report sheet. So that kind of things, if you see upload your report sheet, then you can upload file in that question and then upload your report sheet. And the other question you finish it, right? So it depends upon like our every weekly design. I just cannot guarantee which one going to be for, but we kind of alternate it. Sometimes we have a post lab questions, and one of the post lab question will ask you upload your report sheet, and then that question you have to read carefully and upload the file in that question, and other question you complete as it is. Sometimes directly will ask you, okay, upload your report sheet here with your post lab question. Then at that time you finish your everything and upload there. Okay. That's the thing, and that is always after lab, right? And this pre-lab, when you see pre-lab in pre, everything when you see pre in your assignment, please complete that before lab, right? So uh, sometimes we have a LR. So the LR is a lab report sheet, right? Short form. PL is a pre-lab. So if you see pre-lab PL quiz, then that's before the lab. If you see PL Dropbox or something, PL notebook, I usually label with a notebook. But if you see anything with a PL, then just, do that before the lab. If you see RL reports, LR or RL, that's a lab report sheet, which is after lab. Okay. And after lab that you have to complete and upload there. So Dropbox for report sheet for this lab will be available soon. So you can complete and get ready, scan, have ready them, and then when I open it, you just upload it. Okay. I may have them on Friday or a little bit, earlier when I have time. So during the weekdays, I'm kind of busy with the classes, so I may not be looking at all these, assignment every day. But when I find the time, then I just create it for you guys. So keep checking it, um, you know, like every day, just like Friday or Thursday, or when you finish it, if you want to submit it, just check it. If it is not available, let me know. Also, sometimes I also forget because I have a many section and I thought I posted it and I haven't. So I just want to make sure that you also can remind me if you didn't see Dropbox for report sheet. Okay. All right. Yeah, post lab. No, post lab and report sheet comes together. Those are after lab. Okay. Um, Before lab, notebook and pre-lab questions and pre-lab quizzes. Okay. Post lab and report sheet always after lab. It comes together. All right. So you together upload your post lab questions. So at the end of the class, if it let me log in another screen, I will show you what to do also one more time. All right, so let's go to our today's lab, right? So um, I'm not able to demo you in the lab because they plan to just give you guys data for every other section. So and then the chemicals was not provided for this lab. All right, so I just want to explain a little bit how to complete your report sheet, right? And you will be able to complete on your own. So those who have already written your pre-lab procedure, you might know what is in the A section, right? What kind of reaction you're doing, right? So we are kind of learning like chemicals in everyday life, right? What are the chemicals we use in our everyday life? Can you guys name me? Yeah, that's bleach is one, right? Others? Windex is one, but we don't do for that one right now. So tell me other common things. We don't use directly ammonia, but it comes with some cleansing, right? Table salt, that's fine. Baking soda, yeah, that's very common, like every day we use, right? And any other? Yeah, soda, yes, we use vinegar also. And what are the other things that you use in your like garden and stuff? If you are doing gardening, right? What are the chemicals that you use? Fertilizers, right? So these are very common chemicals, right? We use in the lab. Do you guys know another chemicals that we use, like for the relaxation of your food, like if you go hiking and some long walk, if it kind of stress like your food, if you want to do some, the reduce your strain in your food, we use another kind of chemicals. What is that? Epsom salt, right? So all these are, yes, yeah, great. So we use these chemicals very often in our, the everyday life, right? And if you know what are they, that's fine. Sometimes you may not know what are they, right? You want to find out by some smell or some taste and stuff, right? So what are these chemicals usually made up of? What is this? What is the chemical, this one? What is the chemical used in his here? So this is like when you say bleach, it's like a sodium hypochlorite, right? So it has a kind of like, even though it comes in this chemicals form, that this is very smelly, right? Kind of toxic to smell also, because it is not only this one, it kind of continuously kind of releases chlorine, actually very active chlorine gas, right? So that's why it kind of used in washing, cleaning, because of this one, it will kind of very reactive. It will clean this stuff, dirt very fast, right? And then the here, table salt, what is that chemical? What's the formula of table salt? Yeah, it's a sodium chloride, right? Okay. Sodium chloride. And then baking soda, what's the formula for that? Baking soda, come on, any of you? What is baking soda that you always add in your baking your breads and stuff, right? So what is baking soda? Yes, it's a sodium bicarbonate, right? This one. Vinegar, what is has? What does the vinegar has? Anyone? Vinegar, what is the active component here? What is vinegar? This is like acetic acid, right? So you learn that acetic acid a little bit in your then chemistry one also. So this is a acid, organic acid present there, 5% or 3%, something like that. So this fertilizer, what is this fertilizer? What is it? So it's kind of ammonium salt, right? Some kind of ammonium salt. It could be ammonium nitrate or ammonium other phosphate kind of salt. And then this Epsom salt, what is this? What is this Epsom salt? It's a magnesium sulfate, right? This is Epsom salt with like a 7 molecules of water it has in it. So that is crystal. So these kind of chemicals are common in our household and we always use it. So you're going to learn something like how to find out them. Are they, looking at some smell or some taste? You can find out what kind of chemicals they are, right? So in our section A for our today's experiment, if you looked at the experiment, procedure there, right? In your procedure, household ammonia, right? It says household ammonia, and then asks you to add 1 ml of household ammonia in 150 ml beaker, hold a piece of paper, right? So which is kind of like a red litmus paper, right? And then it asks you to observe the color, right? So you have a kind of like, I'm just going to draw a little bit here, right? Sorry, I'm just so bad. I need to find out a mouse here. Do a good job with this one. I'm trying to like. All right, so okay, let me see if I can draw better with a. So the A section in your report sheet, if you looked at your report sheet, right? So if you go to your case in your experiment 7 report sheet here, right? So what you do is you do a section experiment, like as mentioned in the experiment procedure here, right? And then you go to the report sheet and then fill in that every day in an experiment you do that. So make sure, that's why I asked you to know the procedure. And then when you know the procedure, then you can do experiment easily, and then you can easily know what to put in your report sheet. So in today's the procedure here, the first part A in your procedure A section has a household ammonia, right? So what it asks you to do is, if you are in the lab, sorry, so you're going to kind of ask to do these things, what is written in the procedure. Obtain 1 ml household ammonia. So the household ammonia will be provided to you, right? So you have a kind of beaker here, right? In the lab, we have a beaker. So you're going to use this beaker. So what it asks you to do is add 1 ml kind of like, you know, the the ammonia, right? Ammonia, which is like a household ammonia itself. Right, it asks you to add that, and just asks you to put the litmus paper. It's a kind of paper that we use to test acid and base property, right? So litmus paper blue and litmus paper red, those are available, right? Blue one, and then here is a red one, let's say, right? So the blue litmus paper will change color red if it is like a acid, right? Acid will change blue litmus paper red in color, and the red will change to blue color if it is base, right? So you have ammonia here, right? You put dry litmus paper, so it has to be moist water here, right? You kind of just make it moist in presence of a little bit of water. Then only if you put here will change the color. So if you just put dry litmus paper here in presence of this, then it just evaporate here, right? If you have water here in your litmus paper, moist, right? Moist here, which is like a little bit added water in it, right? Make it wet. If it is moist, when this ammonia gas evaporate, it will kind of mix with the water, and the ammonia and water react to form the ammonium hydroxide, which is a base, right? So this is a base. So if you have ammonia, household ammonia plus water, it will kind of go in. This ammonia evaporates and then touches to the water, moist litmus paper, and then kind of reaction will form the ammonium hydroxide. Then that will change your red litmus paper to blue, right? So this is base, right? So that's what your first experiment was there, right? So if you put just dry litmus paper, it will not turn your litmus paper, the red color, okay, blue color, right? But if you have a moist, it will turn into the blue color. Okay, so if it is base, red litmus paper will change to blue color if in the presence of base. If it is acid, if the paper is blue, then it will change to the red color. Okay, so this ammonia, when it reacts with this itself is like a base, but ammonia is a gas, right? So if it is just gas and you put dry litmus paper on the top of that, the gas just evaporate, it will not react to your litmus paper. But if you moist it, put a little bit of water and make it wet and put it in the top of that, the evaporated ammonia will kind of again reacts with the water a little bit present there, right? And changes ammonium hydroxide, which is also base. So you will see the red color of litmus paper change to blue. Okay, so that's your like the go to the report sheet. It's in my edition, like in my, I'm quite not sure which edition you have. I have 14th edition. So it's in the page 87, right? The report sheet. So go to 87 page and the household ammonia, section A. And I just mentioned that effect of household ammonia on dry litmus paper. Nothing, right? It doesn't change color, like just as it is. So if it is red, it will be red, right? If it is blue, it will be blue. Then if you moist this, right, litmus paper and change, put in there, then what you see, you will see the blue color for the litmus paper. If it is blue litmus paper, it will not change the color, right? So you're provided with blue and red both, and then you're going to moist in the lab. If you are in the lab, then you kind of put on the above this liquid litmus paper, kind of bring it close to here, and then see if it changes the color or if it doesn't change the color. So that's what you have to note. As I just mentioned here, if it is moist, the red will change to blue because the water present in the litmus paper, moist litmus paper, will come into contact with ammonia gas and form the ammonium hydroxide. This is base, right? So in the presence of base, this red litmus paper change into blue color. Okay. If it is already blue, it doesn't do anything. So that's what you have to put. All of you are clear up to 1, 2. All right. Okay, great. And then the 4, like 3, number 3 in the same section, A, effect of ammonium chloride on litmus paper. So if you just put a dry litmus paper on ammonium chloride, does it does anything? Nothing, right? It doesn't do anything. So just you can write that, the color of the same, right? Litmus paper doesn't change. Blue litmus paper color doesn't change. And 4, number 4, effect of ammonium chloride, right? So you have a ammonium chloride there, right? Ammonium chloride. And then it asks you to add like a, let me see closely what it says. So it says place 1 ml ammonium chloride in the test tube and hold the litmus paper, right? So you put ammonium chloride 1 ml solution here, right? Ammonium chloride in your test tube. Sorry, this is ammonium chloride, right? 1 ml. And then you bring your litmus paper here. So if you just do that, this doesn't evaporate, right? This is solution. And it doesn't change anything. It's just solution, clear solution there. And on the top of that, you just put litmus paper. The result is no change, right? No change in litmus paper. You can put that, right? But another thing it asks you to do that after you record that, add in the same test tube, then you're going to add 1 ml, right? What is that? 8 molar sodium hydroxide. Right? So when you add 1 molar sodium, 8 molar sodium hydroxide in the same test tube, right? This is 1 molar, you see If you have written your procedure, you already know, and then 1 ml, right? 1 ml, 1 molar concentration ammonium chloride in test tube. First, you just bring the litmus paper here. It doesn't do anything. Then you add it 8 molar sodium hydroxide, right? So let's see the reaction, what happened here. So if you added sodium hydroxide in ammonium chloride salt, as you already did, kind of like a double decomposition reaction, right? Metathesis reaction last time. This is a cation, this is anion, right? This is cation, this is anion. So it kind of exchanges, right? So if you, another one product is ammonium hydroxide from there. Right? Another one will be sodium chloride. So what happened if you have ammonium hydroxide? The red litmus paper again change into the blue color, right? And then blue litmus paper doesn't do anything, because you see that when you add this, it forms the base here, right? It also kind of slightly decomposed to ammonia gas, right? And the mostly, it doesn't stay longer to that, kind of evaporates. But when you see this addition there, and the formation of ammonium hydroxide, you will see your red litmus paper change into blue color. So just put that in your note, blue. All right, so go ahead, put that there. And if it is blue, it doesn't do anything, right? So the next is 5, right? The 5 number, did you guys do this one? So you should be able to know what's going on here, right? So you have a salt, ammonium chloride salt, which is kind of neutral, right? So before you add this one, it doesn't change any, color of the litmus papers. When you add sodium hydroxide, which is a base, right? Salt, and this ammonium salt, like any ammonium salt reacts with the base, sodium hydroxide base, it produces the ammonia, right? Ammonia, and then the water is already there, so it forms ammonium hydroxide there, right? So you can kind of write the equation ammonia plus water later, or the directly ammonium chloride, that's fine. And let's look at the number 5, right, in our section A. 5. So here it says like fertilizer contain ammonium salt. Yes or no? Yes, right? All the fertilizer has ammonium salts. So fertilizers are usually kind of, if you smell them, since you're not at the lab, you didn't get to opportunity to smell them, but it has kind of ammonia smell. So ammonia kind of like a pungent smell, not very pleasant, right? So it's kind of a little bit pungent kind of a smell. You can easily like distinguish. So all the fertilizers have ammonium salt. So it just asks you yes or no. Yes, if you're in the lab, you kind of smell like you already prepared the ammonia, right? So you already added ammonium chloride plus sodium hydroxide, you kind of already smelled kind of ammonia, right? So the ammonium chloride is also kind of a little bit not that pungent like ammonia, but it's kind of smell faded smell like that. Okay, so on number 5, you can say yes, right? That's right. And then the 6, the smelling salt, those are ammonium, probably, any ammonium salt, right? So let's look at the questions here. So each procedure has a number 4, number 5 record, right? So you guys need to follow that. So it's a procedure. What is the procedure here is first you read your, the section A and see that record your observation 4, right? Record your observation 5, right? Does the fertilizer contain ammonium salt? That's your record number 5. Procedure and the report sheet kind of matching there. So you guys have to follow, they like that. And what is the active ingredient in smelling ammonium? Okay, smelling salts. Add a moist piece of red litmus paper over the mouth of the open jar of ammonium carbonate, right? And carefully fan your hand and over the jar and see if you can detect, familiar odor. So, of course, you smell like, any ammonium salt, like ammonium carbonate, ammonium nitrate, ammonium chloride. You kind of have a little bit ammonium kind of ammonia kind of smell, a little bit, the in the salt form they are not too bad, but they do have some kind of smell like ammonia. Okay, so those things you guys have to know. So, and so what happened, like when you heat ammonium salt, like if you add sodium hydroxide, right, it forms like a, uh, let's look at ammonium salt, ammonium carbonate. So ammonium has a 1 charge, right? Carbonate. Sorry, this crisscross method, you guys know that, right? Ammonium goes like that because carbonate has 2 valency, ammonium has 1. And this is a solid, right? One thing we did is ammonium salt, like ammonium chloride plus base, right? Sodium hydroxide. We did that reaction in our previous section. And here, if you heat it, what happened? If you heat this one, usually when you heat ammonium carbonate, it actually produces 2 types of gas. One is ammonia, right? It kind of gives you NH3 gas, plus another gas is carbon dioxide, right? And plus water. What happens when you heat this? This one will give you salt, right? Sodium chloride salt plus ammonia gas plus water, right? So this one will give you carbon dioxide gas and then water plus ammonia. So when you heat it, also you probably smells ammonia, right? So this carbon dioxide gas is carbon dioxide. I think I have resorted this. This is CO2 I'm writing here. Like this. So this carbon dioxide is not a smelly gas. It is kind of colorless and it doesn't smell anything bad. So when you heat it, if you smell some kind of pungent smell, that's ammonia gas, right? So if you have ammonia gas and already like the water there, then you kind of form ammonium hydroxide, right? Later. And then when you bring the litmus paper, what happened? The color will change to blue to red to blue, right? Blue. All right, so this is your first part A1, right? So these smelling salts are all ammonia, right? Ammonium salt. So you can list the ammonium salt, ammonium carbonate, ammonium chloride, right? Like that, smelling salts. Let's go to the part B. Any question for section A? Did you guys copy and listening to me? All of you? All right, so make sure that as we go, you fill in your report sheet, okay? So this is number 6 is, the smelling salts are ammonium salts, right? You can give the example ammonium carbonate, ammonium chloride, like that, okay? All right, so here, let's go to the B. So B is baking soda, right, in your report sheet. So which is sodium bicarbonate. Let's look at the possible reaction that can go with the baking soda, right? So how much you add when you taste any stuff, it's already provided in your procedure. If you're coming to the lab, then you just exactly add the amount. It is mentioned here, right? So when you look at this section B, you can see that in the beginning, it kind of gives you some background as substances like carbonate, right? Reacts with acid to liberate carbon dioxide. This is just to provide you this some background, and then there is a reaction, right? And then your procedure is start actually from the paragraph 2, right? Place a small, like the dry test tube, right? So what it says is place a small dry test tube, right? And add small amount of baking soda. You add sodium bicarbonate here in the test tube, right? So sorry, it's CO3. So how much you ask to add is small, like a pea, right? Like a small pea. So that means like a very little amount, like this much from your scoop. When you scoop with the things, just very little, right? So this small piece you add here, it's a solid, right? As you already used this in lab. So once you add this, then it asks you to add 1 to 2 drop, right? You can add 1 drop and see if it doesn't do well, then you can add at least 2 drop, 1 or 2 drop. This is what you have to exactly write in your notebook. P size sodium bicarbonate was is first transfer P size sodium bicarbonate in a small test tube, then add 1 to 2 drop sulfuric acid. That's your procedure for this part B, right? As you go, there is a more. S2SO4, 1 to drop sulfuric acid, which is S2SO4. So when you add this, what happened, right? So in the above of this procedure, it just say that any carbonate, when you add acid, it will give you carbon dioxide, right? So here is also baking soda is sodium bicarbonate. When you add acid, then the reaction, what you expect is one product is always carbon dioxide. Acid reacts with bicarbonates, carbonate salt to give carbon dioxide. And then another one is water. And then there is a salt. So here is a sodium, there is sulfate left, so it's going to be sodium sulfate. Like this, right? So in the book, you just see that sodium plus, right? But actual, you can use another acid also, any salt, that's common reaction given for. So if you add sodium sulfuric acid, the reaction will be this. So this gas is produced, right? This is gas, this is liquid, and this is salt in aqueous form. So your second one is you have to write that. Okay. When you add that, if you're in lab, you add the acid here, these 2 drop here, and you kind of see some bubbling here, the colorless gas bubbling in your test tube, which is carbon dioxide gas. Okay. So so your reaction going to be here, like sodium carbonate plus sulfuric acid, this one. Okay, you can balance your own because you already know how to balance it. This is your 7, right, in your section B. Now let's go to the 8. In 8, it's a baking soda plus sodium vinegar, right? So baking soda. What is this baking soda? So same thing, right? So we already know it. So it just asks you to do vinegar. As I already mentioned, you guys, vinegar is like a acetic acid, right? It has this one. This is also kind of acid, right? Very low percentage and weak acid. This one is a strong acid. So right, still it will do the same thing, right? So any acid in presence of bicarbonate, you will get the same reaction. You will produce sodium instead of sodium salt. Here you might produce sodium acetate, right? So this is whole thing here is a acetate, right? And this one is acid, S plus. So here is a sulfate and then S plus, and then this is the salt, same salt. So you're going to produce sodium acetate, right? Instead of sulfate, you're going to have sodium acetate like that. CH3COOS, or you don't have to even write CO only like this. Sodium CH3COS. So this is whole thing is ions, right? This kind of negative ions from here to here. And then other thing produced is same, like a carbon dioxide and plus water. So this is a gas. So when you add this one, vinegar in your sodium, similar way if you put in a sodium bicarbonate in your test tube and add vinegar, you will see some carbon dioxide colorless gas bubbling there, right? You can see kind of bubble emitted there. And then other thing is soluble in water, it remains in the clear solution. Yeah, but did you note it? Up to 7, 8? All of you able to note it? So this is NaCH3COO. I just put it parentheses here, right? So you can just write this and this combined. Instead of parentheses, you can just write this way also. Sodium CH3COO. Or we can write sodium here. And then CH3CONA, or either way, fine. All right, so let's go to the section like a 9, number 9, okay? So B and 9. Any question so far? All right, so in the 9, it said chalk contains carbonate ion, yes or no? So you guys know that chalk, right? So we write that in a blackboard. These days we don't use so much, but in past, this is the one of the teaching tool, right? So chalk is, what is chalk? What is this? Anybody? What is it made of? So chalk is usually made of calcium carbonate, right? So this whitey stuff is always called calcium carbonate. So if you add, what do you say? Chalk contains carbonate, yes or no? Like, this is a carbonate, right? So you say yes, like in your 9, first you say yes, because you see that this is a calcium carbonate, right? So this is a carbonate salt. So you just say yes. That's your B, okay? Now let's go to the C, section C. Everybody clear about that? What is chalk? Chalk contains carbonate, yes or no? So make sure that you understand it's yes, right? Okay. And now let's go to the C, which is like a table salt. As we already look at this table salt, which is kind of like a sodium chloride, right? So your 10, number 10 there. So you can also look at in your procedure what it asks you to do, right? So in our lab, we do a little bit more work and do a little bit more confirmatory test also. But in your like part B, it didn't put more information there. But in a lab, we kind of do some test more. If it is carbon dioxide, the further confirmation test. Carbon dioxide, if you want to confirm that whether that carbon dioxide gas is there or not, you can, they use barium chloride, okay, barium hydroxide there. Barium, sorry. I'm just going a little bit further because when I go back in procedure, it has a. So if you have a carbon dioxide gas, if you want to confirm whether that carbon dioxide gas is there or not, you can just add, the barium hydroxide, and then it will immediately form insoluble barium carbonate, white precipitate. This one is a clear solution, right? So when you add this in this test tube that has carbon dioxide, you will see the barium carbonate, which is insoluble white solid, right? And then the water forms, it will remain there. So if you didn't add, if you see bubbles, that's also confirmatory, okay, kind of like, the presence of carbon dioxide. But if you really want to confirm, any colorless gas cannot be only carbon dioxide, right? If you want to confirm really it is carbon dioxide, you add barium hydroxide, and then it precipitates as a insoluble white solid. Right, so that's STL par 9, but on the report sheet doesn't have that information, but we do have in our, the procedure though, right? All right, so let's go to the 10, part C, like section C. So section C has a little bit background in the beginning, right? So that's how you make yourself a little bit confident, and then procedure starts from place in a small dry test tube, like that's what the procedure is, right? So again, it says place in a small dry test tube and a small amount of sodium chloride, size of P. So you add sodium chloride here, right? Size of P. So very small amount, right? You have a spatula, like to measure it. So just you take very little amount here and transfer here. So you have a very small size P sodium chloride there. Then if you want to find out whether it is sodium chloride or not, then you add sulfuric acid, right? Sulfuric acid. So all these salt, like any chloride salt, in presence of sulfuric acid, it gives you the, the gas, HCl gas, right? So if you react these two, or any chloride, potassium chloride or any other chloride, when you add sulfuric acid, this salt will give you the HCl gas. So here, like HCl, let's see, sodium chloride. So the gas produced here after you add sulfuric acid here, right? Then that's the HCl. So another acid produced here. See, so this HCl, it's kind of pungent gas, very irritating, very bad, right? And plus you say salt here. You can balance your equation, so you can produce 2 HCl, sulfate salt, actually it has Na2 here. So you kind of produce this HCl gas, and you can easily, they also, from the smell, you can kind of identify it because they are more pungent smell, right? So let's see there. So you can write that gas, like a pungent smell gas produced in the number 10, right? And also in the reaction, you can write this one. Is that clear? Everybody? So make sure that in number 10, effect of H2SO4 in a sulfate, right? Table salt. This is your table salt. When you add this one, just mention that, pungent gas smell. So the HCl is kind of pungent gas. It's kind of eye irritant also. And the remaining is salt. So the second part, like 11, this is going to be 11. The observation part, when you add there, HCl gas produced, which is kind of pungent smell. Okay. All right. So next, like there is a more test here. If you're in the lab, we kind of again, they test that more, right? If you have HCl, not only sodium chloride, if you have KCl provided, it will do the same thing. You add sulfuric acid, it will do the same thing, right? It will give the HCl gas, and instead of sodium, it will produce the potassium salt. So to confirm this, like the sulfuric, hydrochloric acid kind of ionized chloride plus this one, right? So any salt present, like that has a chloride ions, right? If you have a chloride ions, if you want to confirm that whether there is a chloride or not, then if you do AgNO3 test, this is a silver nitrate is called, right? Ag is a silver and NO3 is a nitrate. So with the silver nitrate solution, right? Silver nitrate solution ionized minus this plus this like this. So what it does is these two kind of like, come together and precipitate. As you already did in your metathesis reaction, right? In your like a um, experiment like 20 or 21 in your general chemistry 1. So this kind of precipitated as a white PPD, right? White color. So this is the most common test for chloride. Any chloride, if you add AgNO3, it will precipitate. So one thing, you can add sulfuric acid and that forms the gas. Another thing is you can have a salt solution, plus if you add AgNO3, it will precipitate white if it is AgCl, right? Salt form. If it doesn't form any white precipitate when you add AgNO3, then there is no chloride there. So this is another confirmatory test for chloride. Okay, is that clear? So let me see what is in your, yeah. So bar 12 number. So any salt, like if you have a sodium chloride salt here, if you add AgNO3, this is silver nitrate, right? Silver nitrate solution. And this is the sodium chloride. So both are very clear before they mix. Once you mix it, then it will change into the white precipitate, right? So if you see white precipitate, that's a silver chloride, and then that will indicate you chloride is present in that salt that you have. Okay, if you don't have chloride salt, it will not precipitate white color things here. All right, so you go write that in 12, right? So the effect of AgNO3 on table salt, you can write white precipitate, right? And then you can also write this reaction. And now let's come to the 13. So in 13, why use distilled water? Like distilled water is recommended for this test, right? So why? As you know, in our tap water, right? Tap water has always some kind of chloride salt present, right? So the chloride present in so if you make this solution, sodium chloride in tap water, then you don't know that chloride is from your this salt or from the tap water, right? So in order to avoid this confusion, we always use this, distilled water. Distilled water doesn't have any ions, right? No ions. it is just water, H2O only, right? Tap water does have lots of iron, chloride, other ions, right? Bicarbonates and stuff. So in order to avoid this confusion where the chloride is from here or tap water, we avoid to use this tap water. And if you use distilled water, there is no ions there, right? So we would assume that the salt is chloride, and then that's what we're using. Otherwise, if you make this salt that you want to taste, if you dissolve in tap water itself have chloride, and you don't know that salt you're using has a chloride or not. For that reason, we kind of avoid to use, the tap water. So you can explain this. Are you guys clear? All of you are clear? Okay, great. So any of you have any question, please do not hesitate to ask. I have microphone open, so you can also type in chat. And now let's go to the 14. So in 14, chloride ions in the tap water. Yes, right? So chloride ion, I would like to just say yes. And the salt in phlegm. So one more thing here, I want to say that in a 15, let's go section C, 15 number. Right, so in a 15 it says salt in phlegm. Right, so this salt in phlegm means that you take a small amount of salt in your spatula, right, the metallic, the scoop that you have in your lab, and then just heat it in the flame, like you have a Bunsen burner or something, right? I have a flame here. So if you heat this in a high flame, this sodium salt, right? Anything that has a sodium, it kind of burns like the yellow color, yellow flame. So your another experiment part is you take a little bit in a scoop, right, and put under the above the flame, like a high heat, very high. Bunsen burner has a temperature around like 600, 700 degrees centigrade, right? So if you put that spatula with your sodium chloride salt, this salt will burn with a yellow color, yellow flame color. Okay, so that will confirm you that is their salt is sodium chloride, right? Is that clear? So you write that the salt in flame is yellow for the sodium, right? So also you can write sodium ion present. So one way you want to find out what anion present, what ions present, right? This is sodium ion burns, like when you burn it burns yellow, but if you want to find out chloride or not, then AgNO3 test, right? We already just did it. Then it will reacts with this, and then from AgCl, which is white precipitate. So two tests, right? This one gives you chloride confirmation, and when you burn, if you see the sodium, then it will burn with a yellow color. If you have potassium, it will burn with a violet color. If you have lithium, it will burn with another color, right? So crimson reddish color. So they have like a different salt, like a cation have a different color when you burn. So this will confirm you that your salt is sodium chloride. Is that clear? All right, so let's go to the part D. So D is a Epsom salt. So as I just mentioned that this salt with 7 molecules of water in it, right? If you just say sodium magnesium salt, it's a dry anhydrous. We also use this sodium anhydrous if it is has no water in, like drying the reagents, right? So if you want to keep something dry, we also have this anhydrous magnesium sulfate added in it. But when you say some salt, that has a 7 molecules of water with it, right? So this is like this. So hydrated salt. So if you remove this water by heating or some way, it becomes anhydrous, right? And those are useful to absorb the water from the other stuff. All right, so let's look at the 16 in our worksheet, right? So you can also look at the procedure in D, right? In your procedure, it says like a place a small amount of like a first 1 2 round is like a line is just to give you the idea uh, what is it used for, right? And the actual procedure starts from place. So when you write in your notebook, you don't have to write all the explanation that's given. You have to find out the exact procedure. That's what it is. For section D, you go to line 3 and then just start writing. Place a small amount of Epsom salt in a small dry test tube and add 1 to 2 drops of 18 molar sulfuric acid. That's your stepwise exact procedure there, right? After you finish that, then you can record your observation in your report sheet. You need to put that one also, right? And then the other things there. And then another procedure is like also place some Epsom salt in a small dry test tube, dissolve in 1 ml distilled water, add that one. That's another procedure continuation of your Epsom salt test, right? So you guys need to know that what is procedure, what is not, right? Sometimes the lab procedure gives you a little bit of background so that you will understand what is going on, right? And sometimes they directly start from procedure also. So what you need to put in your notebook is just put exact procedure, what you need to do for that experiment, right? So in this case, you can kind of start with line 3, place a small amount of Epsom salt in a dry test tube, add 1 to drop that, and continue to other procedure. All right, so here also the same thing. So you're going to put the Epsom salt in a dry test tube, right? So Epsom salt. Right? And then what you're going to do is you're going to add like, the 1 or 2 drop S2SO4. So in this case, when you add sulfuric acid here, right? What do you expect? Do you expect anything to happen? This is a magnesium sulfate, right? Actually, it doesn't do anything because this is sulfate and this is sulfate, right? It's no reaction going on here. So you can write in a 16, effect of sulfuric acid in Epsom salt, it will not do anything. So just write no reaction, right? And then you can write the second like a, sorry, where are you here? Okay, so the another one is, you can write this and this, add this one, no reaction, right? This plus this, you can write no reaction. And another one is 17, right? So if you didn't do anything here, let's continue to the procedure section. Record your observation like you did that, right? Note the difference in behavior of this substance toward sulfuric acid and comparing the. So if you look at in previous section, when you have a baking soda, you added sulfuric acid and it's acid, right? That kind of gives you the carbon dioxide gas bubble, right? But here, if it is magnesium sulfate salt, it will not do anything, right? So that thing you kind of notice in your lab if you are. But if you haven't done that anything before, I just want to say that it doesn't react, no bubbles, anything, okay? No gas bubbling, anything. So now the continuation of that procedure. So once you put this one, no reaction, you kind of dispose it, right? You dispose it, and then you again start with a fresh another test for magnesium sulfate. So another test is you have a sulfate, right? magnesium sulfate, let's say, minus what it says, replace magnesium sulfate and add nitric acid, right? 1 drop. I think it will kind of dissolve this properly, right? If you add this. And then again add 1 to 2 drop barium chloride, BaCl2. Then at that time you may see some kind of like a precipitate there, right? So if you add this magnesium sulfate, it's a clear solution, right? In water, right? Clear solution. And then you add nitric acid to make it dissolve very clearly, right? And then when you add this barium chloride, so before you add here, it is also clear solution. So when you mix these two, then you will see some precipitate, right? You will observe the white precipitate. Let me just write here again. So you have a magnesium sulfate, right? And then barium chloride. Barium chloride, BaCl2. So when you do this, then as you know, this both are soluble clear solution, right? Before you mix, when you mix, you see some kind of precipitate and magnesium chloride, right? So this is still soluble clear solution, right? And this is insoluble, and then it will precipitate. So what you see here is when you add barium chloride to this one in a test tube, right? MgSO4 here. You add barium chloride. Then you kind of see that test tube color here, precipitate, white precipitate. So that's your observation. You see the white precipitate, and that white precipitate is this form. The white barium sulfate is insoluble white precipitate. Okay, so you can write that in your things. This is the test for magnesium sulfate. So if you add any sulfuric acid here or any acid, it's not going to react. But if you add barium chloride, it will react to form barium sulfate, and which is white precipitate. Okay. So barium chloride test is a confirmatory test for sulfate there, right? Mm-hmm. All right, so that's your part D, 17 and thing. So any question for this D? So we did 17, one of them no reaction, other one is the white precipitate, which is a confirmatory test for magnesium sulfate, and this white precipitate is due to barium sulfate formed there in the reaction. Okay, so this is kind of also double displacement reaction, right? So it will displace, like the two of them, anion displaced, right? So anion put it here, this one goes here. So all right, so let's look at E. Okay, section E. So in this one, bleach. So another household chemicals you use in the in your house is bleach. So as I just mentioned, this is sodium hypochlorite, right? COCl. This is a formula. But this chlorine usually kind of like it constantly gives chloride ions and form chlorine gas here. That's why it gets very difficult to breathe and stuff. So it's kind of toxic. So make sure that you're not using too much bleach at home. Okay, so that means like you're breathing lots of this chloride gas there. So it kind of continuously decomposes to this chloride gas, even though this is in this form. So it kind of eventually it kind of gives this one. Okay. So this chloride is very reactive, right? So and very pungent as well. You kind of observe in the house when you clean with the bleach. And this bleach has a since this has a chlorine, it kind of property that it can displace the the iodine from any iodide salt. If you want to find out whether this is chlorine or not, if you put a little bit sodium iodide salt, right, in there, then you kind of will see the iodine gas formation there. And sodium chloride. So sodium chloride, as you know, that is soluble in water, right? And this one is a kind of reddish color gas, reddish brown color, I think. You have seen the iodine, right? Tincture iodine, kind of like that, reddish, slightly not very, very reddish, but it's kind of, I don't know how to mention that. It's a brownish, reddish color gas. So if you add a little bit sodium iodide in your, the bleach, you will see that iodine gas form there, right? Iodine gas. You kind of displace this one. So this one is more reactive than this one. So it will take the place of sodium, the iodide, and displace this one. So yeah, then you will see this gas coming off in your test tube. So if you're in the lab, then you just, as it mentioned here in the procedure, right? So in a small test tube, so all these like almost a paragraph here is a background for your, the understanding this experiment. Your actual procedure kind of start from in a small test tube, dissolve a small amount of sodium iodide, right? And add 1 ml distilled water, add 5 drops bleach. That's what it is, your procedure. So you have to write in your notebook like that, right? You don't have to copy whole thing. It says like a small test tube, right? Dissolve a small amount of you add sodium iodide here a little bit, right? And then add water, right? Distilled water. As you know that chloride is in tap water, so distilled water you're going to use it. All right, so distilled water, and then you kind of add your bleach, it says like a 5-drop bleach. So this is your actual procedure in lab, right? So when you write the procedure, you don't have to write whole thing, commercially bleach is 5%, blah, blah. That is to understand for you, right? So you read that, but you don't put that things. But you will have to know that what is the, the color of the chlorine gas or, the iodine gas, right? So this is kind of reddish brown, and this gas is kind of like, the pale yellow. So you don't really see the very strong color. It's kind of pale yellow if it is too concentrated. So in house, like in presence of this, it kind of constantly releases this. And if you want to find out whether it has a chlorine or not, you kind of test with a little bit sodium iodide, right? Add few drops bleach here, then you will see that reddish color gas evolution here. Kind of gas comes here, right? Iodine gas is there. So that's kind of confirmatory test for iodine, okay, chlorine. And another test you can also do here is like, the whether this is iodine gas or not. If you put like, in this one, like, AgNO3, let me make it another one here. So as I just mentioned in table salt test also, AgNO3 kind of test with all the iodide, right? If you have iodide or chloride, you can test this, right? So if you have iodide, it will gives you like a Ag iodide, AgI, silver iodide. If you have a chloride like this one, then it will form like Ag chloride, AgCl. If it is AgCl, it's a white color, right? White color. If you have AgI, if you test with iodine, then it will be like a, the yellow color precipitate. So you kind of get some idea from the color, right? So what is that? It is iodide or the chloride. So let me see your report sheet. So here, yeah, that's what it is. So if you have a silver and if you want to test sodium iodide, right? Sodium iodide plus AgNO3, it will give you silver iodide. And if you're in the lab, if you add these two, you will see yellow precipitate. That means like it's a silver iodide, right? The remaining part will be salt and sodium nitrate. So you can still continue to write sodium nitrate also here. But the color is from your AGI. All right, so and the 20 is like, this is your 19. Now let's come to the 20. So 20 has the effect of sulfuric acid is 2SO4, right, plus NaI. So what will happen here? Anyone? So as we know that, like when you add sodium chloride, right, in a sulfuric acid, we did that in our stable salt, right? Any acid, right? When you add this, then you see that HCl gas formation, right? Pungent gas. But here you will see HI, hydroiodic gas. But the other things will be same. It's a sodium sulfate here, right? That will be also same. So only the salt will be the same here too. And yeah, you can see that. And then there is a furthermore in the lab to test, but the report sheet doesn't ask you to do more than that in your lab. But if you're in the lab, you're going to do more observation here, right? It asks you to do observe with the silver nitrate, right? Those kind of things. Solid sodium sulfur start turning to brown color, right? Fume gas forms, like if it is forming brown color gas, that's place a small amount of the sodium iodide in a small test tube and then put 1 drop of the sulfuric acid, record your observation. So just tell that it all forms the yellow precipitate there. That's it. And then once you've done that, then you dispose it. All right, so here, pretty much done, right? So experimental part. Apart, yeah, like I just want to, if is unknown. So after all these tests in the lab, what we do is we give you guys one solution which is unknown, right? One salt, like a white color salt. We give you guys salt, white color, right? And then we'll label unknown. And you will have to kind of find out in the lab what is that unknown by looking at all these properties that you know now, right? So how to find out this? So you have to first follow that if it is salt, like a sodium chloride, also like a salt, right? Sodium bicarbonate also salt, right? And then magnesium sulfate is also salt. So if I give you salt and then you add a Cl, or sulfuric acid, right? All of these are white color, right? Magnesium sulfate, all white color. And you want to find out which one is this, right? Which salt it is, because the bottle has like a white color salt and you don't know which one it is. So if you want to find out which one out of these three, right? or other KCl or other any salt. First of all, what you're going to do in age test tube, you take your unknown, you put in a test tube. For this week, I will just leave it, but next week I will start turning late sign there too. Okay, but make sure that as I just mentioned that it's before the lab. We'll come to that in a little bit if you have a question. Let me finish that experimental part. So you don't know which one is it, right? Which salt is it? So what you're going to do is your unknown, you put in a test tube. Sorry, just spelling wrong. Unknown, right? I'll just cross this unknown here. And you have a tiny bit unknown, then you add, let's start with sulfuric acid test, right? If you add sulfuric acid, if you see some kind of bubbling there, you may think this is like, sodium bicarbonate, right? Carbonate salt. If you add, the sulfuric acid, if it is salt, like a sodium chloride or potassium chloride, any salt that has a chlorine or iodine things, so you might see another color of gas and kind of smelly, pungent smell, right? The sulfuric acid, when you add NaCl, it produces HCl gas, right? It's kind of smelly, like, it kind of irritant, just kind of like a very pungent smell gas, right? And if you see that pungent smell, different smell there, then you kind of go to AgNO3 test there, add AgNO3. And if you add that, it will gives you AgCl precipitate. But if this one also comes wrong, and this doesn't give you like a HCO3 plus H2SO4, right? If you do this, then it will kind of gives you one carbon dioxide gas bubbling. And if you want to test this carbon dioxide gas or not, you can add barium hydroxide, right? And then see barium carbonate white precipitate to confirm this. But none of this, when you add sulfuric acid, it doesn't give any gas, and it also doesn't give any pungent gas here, right? It doesn't give any taste here, right? So now if it doesn't give anything, it could be possibly this one, right? Magnesium sulfate. As you know that sulfuric acid doesn't react with magnesium sulfate. So then you're going to have a what confirmatory test that you're going to have, you'll have to find out yourself. Now I said like unknown ions, sulfate, okay? So you can write your unknown ions salt like this. And then the 22, you're going to find out what you're going to do by yourself. Like as I say here, for the confirmatory test, if it is HCl gas, you add AgNO3 and HCl precipitate, right? Here, if it is bicarbonate, you from the carbon dioxide, you want to do confirmatory test, add barium hydroxide, and it will gives you barium carbonate. But if your unknown has a sulfate, right? What confirmatory test you will do? You have to find out that yourself. Read your book here, right? Go to the Epsom salt, and then the second part, the sulfate plus barium chloride, that's your confirmatory test, and what will form, right? Those things you have to write it in your, the unknown. All right, so with this, I actually done with this experimental detail. I hope that all of you kind of fill in your report sheet one by one. Any questions in the report sheet? Any of you? Any questions? You can speak if you are not clear. Report is due a week from today. Like it will be stated like probably today is Monday, like probably Sunday night, late night, last, or sometimes I can even put like a 5 p.m. of today. Okay. In the report sheet also, you kind of write this observation that what you did it. if you have calculation, you collect the data there and calculate it. But to complete your reports, okay, lab notebook, you can kind of complete what you observe here, right? All these things. Just write all these report sheet data and observation same way. Yeah, post lab will come with this. Post lab you have to do yourself. Read the lab manual and then get the information, introductory part and stuff. And then this, the things that we already discussed it. So you should be able to figure it out. So sodium carbonate and bicarbonate, they are pretty much same reaction, right? So what happened with HCl? Very simple, right? So if you add any acid in carbonate, what will happen? Carbon dioxide gas produced, right? So those things you have to uh, write it there. And then I think pretty much we kind of cover here, like sodium chloride and sodium iodide with a silver nitrate test. Like if you have sodium chloride, it will give white precipitate. If it is sodium iodide, it will gives you like the yellow precipitate, right? So those kind of things. So if you go to your lab, the uh, some of them I'm going to check it out. How many post lab question you have to do it, right? I think I'm going to find out that what we have in our the post lab report sheet. I think you don't have to do separately if it is already question in your. Let me check it out. One more thing I want to show you here. Just hold on for a few minutes. I'm going to find out how it is designed. I have to upload though. I haven't uploaded yet, so I don't know right now. You really cannot see until you upload. So I haven't uploaded anyway. Just what I want to mention yet. Sometimes, let me just okay. Sometimes like a post lab and the questions plus report sheet, right? It's posted like a quiz, post quiz like kind of stuff, right? Post quiz kind of stuff. Quiz, because it's hard to grade all the post lab question one by one. So if we put in quiz, then it will grade automatically. So we kind of like to do that. Sometimes we don't have time, we don't do that, right? So this one will be like this in your like if you see the quiz type after post lab, like after the lab, if you next time if you didn't see the Dropbox and if you see the some quiz posted after post lab, then that means like it has a question number 1, 2, 3, right? So it has a post lab question, post lab question, post lab question, and question number 4 it will say upload your worksheet here, report sheet. Like if you have done your like a lab 1 general chemistry 1 sheet here, right? It might be like that kind of style, and students always forget to upload here and then just finish this question. And if it is like this, you don't have to they do post lab question separately. You just do the post lab question listed here and upload your report sheet. Those post lab question is from lab manual. So you kind of sit there, complete there, and then the report sheet you first complete, scan it, get ready, and then when it comes to these questions, then go to the file, upload here your report sheet. Okay, is that clear? Anything not clear? So make sure that if you have done already like the general chemistry 1, sometimes like we have this blended, right? So the report sheet will be in one of the questions in post lab section, and at that time you don't have to do separate post lab question unless it is asked you separately do, right? So the post lab question are maybe not all of them are typed here, just a couple of them. I haven't looked at it because you have to upload it to look at it. You just cannot see it without uploading it. So I will kind of think it has these questions, and then one of the question has upload your report sheet here. So don't forget to upload your report sheet. And people like some of the student doesn't read question properly, and then you forget to upload here. Okay. So check your points, and they make sure that you did think properly. All right. So with this, I kind of like finish my uh, lab one today. If you have any question, let me know. Otherwise, I like to end the session. Any questions? Did you guys get the data collected all of them? So I'm not going to post the separate data sheet. Make sure that you have collected your data while I was explaining. Okay. All right. So okay, then I want to end the session. If you don't have any question, go ahead, complete your report sheet and find your unknown. So for the unknown, I gave you guys sulfate ions there. So the confirmatory test, you find out yourself what confirmatory test need to do if it is sulfate ion to confirm. Okay. So there is a confirmatory test in your lab manual. So read it. We also explain here again, right? To apply your knowledge, make sure that you know what is your confirmatory test for your sulfate ions, right? All right. So go ahead, complete it, right? And I will see you guys next week. And also another thing is you have a like office hour for your section, 2L3. Uh, Yeah, before your class, like 11 to 2 p.m. on Monday, I put you office hour also next week, right? Also, like another section has office hour Wednesday, 12 to 2. So if you want to have some office hour, you can email me. I will kind of, give you the guest link for Wednesday if you want to meet on Wednesday, right? Otherwise, if you looked at in your Blackboard, there is an office hour meeting. So within that hour, so all the week sessions are already open. So I didn't open the week like 2 days session because it's kind of complicated. So I give every section like a certain hour virtual meeting. But if you want to meet in another day, like a Wednesday, you will have to email me, and then I will kind of invite you, give you some guest link. Okay. So that's available for you, and then you can join to another section and we can discuss the same. But I'm not going to open the day for you virtual meeting. So you have one virtual meeting, and another day if you want to meet on a Wednesday, send me email. Then I will send you guys, the guest uh, invitation so that you can join the other sections office hour. All right, so with this, I want to, you're welcome, all of you. Thank you, and I will see you, some of you next week, and some of you in the lab, and some of you in the virtual meeting. You're welcome. Have a great evening, and stay safe. And I'm hoping that all of you have a negative test for COVID, right? Have you guys already tried it or you haven't hit it? Make sure that before you come to the lab, you do test and make sure that you are, negative. If you're tested positive or your result hasn't come yet, please stay online and watch. All right. Do not email me the results. You don't need to email me results. Just make sure that if you don't have results yet, the wait to come to lab. But if you already have a result like a negative, you come to the lab. If you have tested positive, you stay home and watch from home, get rest, and get recover. All right. Welcome. Okay, so now I end my session. See you guys next week.